Okay, this is the second page of our practice test for our functions trig test on Chapter 2. And we have these graphs and they're talking about increasing, decreasing, and constant. Most folks have got this down fairly well. All right, look at this part of this graph. Is my pencil moving up? Yes, it is. Therefore, it is an increasing function. All right, right here. Where is not the function value, where is the x value of my pencil at? It's at -2. So this interval is going to start at -2. And where does my pencil quit going up? At x equal -1. Okay? Notice I use a parentheses and not a bracket. Okay? Now, if this function were to continue like this or like this, then I could clearly see before and after this point it is increasing. But when it's just a point like that, I really don't know what's happening at this point. As soon as I move away from this point, I go, oh, yeah, it's getting bigger. It's increasing. What's happening to my pencil here? It's neither rising or falling. So that is a constant interval. Again, we always define what is my x value. Well, -1 all the way to +1. All right, and what's happening to my pencil now? It's going down the paper. So that is a decreasing interval. Where's my x value at this point? 1, +1. Down, 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 and then I stop going down right here. What's my x value? +3. All right, so on and so forth. Max and min, bumps and dips. Here's a bump, here's a dip. What is the x and y coordinate of that bump? Well, it is -2, and the value looks to be about 18. That's a maximum. That's what we call our bumps. What's the x and y coordinates here? Well, it looks like 2, let's say -14. That's a minimum because it's a dip. All right, probably need to write this in function notation. Okay, so the minimum occurs at x equal 2. The value of the minimum is -14, and that's how we say that. Rate of change. Okay, this is what we did instead of the difference quotient. Okay, rate of change, I'm basically asking you just to find the slope between 2 points on a graph. That's what rate of change means, it's slope. So what I need to do is I need to evaluate my function first at 2, and then I need to evaluate my function then at 8. All right, so I'm going to plug in 2 into this function here. I'm going to get square root of 4, that's 2. I'm going to plug 8 into this function here. I'm going to get square root of 16 is 4. So what does that mean? I have two ordered pairs, 2, 2, and I have another ordered pair, 8, 4. Find the slope between those 2 points, and you found the average rate of change. Odd, even, or neither by looking at the equation. Okay, well, I have 3 things. First of all, I have the equation, f of x. That is given. All right? And then what I have to do is I have to substitute in -x and find that function. And then last but not least, I need to find what we call the negative of the function. Okay, here I'm substituting a negative sign in here, so that is literally -x to the 5th minus -x to the 4th. All right, to an odd power, this is going to be negative. To an even power, this is going to be positive. So that's going to look like that. That is not the same as my given function. So it is not even. Okay, what does this say? This says I'm just going to distribute a negative sign throughout my entire function. Okay, None of these match. This does not match with this. This does not match with this. This does not match with this. So it's not odd. So if it's not even, it's not odd, it is then neither. Okay? Now, how do I tell by looking at a graph? And a lot of confusion on this. Most people understand pretty much they can look at this graph and go, oh, I see that graph. It's symmetrical. Why is it symmetrical? Because I can split it in half with a line. Now, if this line so happens to be the y-axis, then your symmetrical function will be even. Okay? I have to have two things. I have to have line symmetry, and that line of symmetry has to be the y-axis. I satisfy those two, it's even. Let's say I had a function over here and it's split by x equal -2. Is it symmetrical? Yes. But is the line of symmetry the y-axis? No. So it's neither. Okay? I have to have line symmetry, and that line has to be the y-axis. I'm even. All right? Now, there's another type of symmetry, and it's called point symmetry. Okay? And what is point symmetry? Is I pick this point, and the distance from here to here is the same as the distance from here to here. Distance from here to here is the same as the distance from here to here. These kind of look like a double image reflection. Reflect this here, and then reflect this here. Okay, we call that point symmetry. Now, if I have point symmetry and that point is the origin, again, it has to be both. It has to have both point symmetry and the point has to be the origin. It's odd. Any other situation, it's neither. Okay, so that's how you tell even and odd by looking at the function. That's how you tell even and odd by looking at the graph. So what is this guy? Even. It has line symmetry, and that line symmetry is the y-axis. All right, third page, third video. See you then.